All right, so we back. This is Professor Parker, and for today's lesson, we're getting more into some Eureka math, grade 6, module 1, lesson 20. And from lesson 20, we're going to look at problem letter F. Problem letter F. All right. Lesson 20 is about unit rates, ratios, and proportions. So if you're watching this video, you're probably following along. You probably have your Eureka math book in front of you, or you have access to the actual problem as it's written. As you can see, I did not take the time to write the actual problem out on this board. It's just too much writing. But I am going to read it. And I'm going to write some information from the problem. I'm going to write the chart or the table, and I'm going to write the graph. I'm going to do like a quick and dirty sketch of the graph so we can work with that. All right, but let me just first start. It's a word problem. So first thing we got to do with word problems is we got to read them. We got to read them, and we got to become familiar with them. All right. Now, letter F says, Emilio wants to buy a new motorcycle. He wants to buy a new motorcycle. All right. He wants to compare the gas efficiency, key word or key term, gas efficiency for each motorcycle before he makes a purchase. The dealerships presented the data below. Right now, I am going to put this up. There's a table. There's information on the sports. He's got two choices, a sports motorcycle or a leisure motorcycle. So a sports bike or a leisure bike. All right. Now there's a table that gives him the information about how many miles he can travel on a certain amount of gallons of gas for the sports motorcycle. But then for the leisure motorcycle, there's a graph. So you're looking at a graph where you got points, you got an x-axis, then you got a y-axis. The number of gallons of gas is along the x-axis or the horizontal axis. The number of miles that can be traveled is written across written adjacent to the y-axis, which is vertical, right? And then you got points. All right. Excuse me. Those are coordinates, right? Those points are coordinates. Now, first off, let's back up. Let's back up a little bit, because I know that people read this problem and the problem may seem difficult to them, but the issue with the difficulty has nothing to do with mathematics. The issue is one of terminology and vocabulary. Gas efficiency. What is gas efficiency? If you read this problem and you don't know what gas efficiency is, you're going to be lost automatically. Like from the rip, you're just going to be lost. So what I want to do is take a moment and just have a little conversation about what gas efficiency is. Gas efficiency basically tells you, if you got a vehicle, some type of vehicle, it could be a car, it could be a dirt bike, could be a motorcycle, whatever, how far that vehicle can travel on a certain amount of gas. We know how vehicles work, gas-powered vehicles work. You put gasoline into the tank, the engine then burns the gasoline, and then you're able to accelerate and move, right? So gas efficiency measures, okay, how much gas do I need to go a certain distance? Like some cars that have, for example, if you got cars that got a high gas efficiency or high gas mileage, that's synonymous. A synonymous term is gas mileage, or how many miles per gallon, right? Pay attention when you see those car commercials that come on YouTube or when they come on TV or wherever you at, right? Look at the miles per gallon, right? Because some cars have a lower miles per gallon, have a higher miles per gallon than others. That's why you see some people driving around in real small cars. You might look at them, you might laugh or whatever, but at the end of the day, that small car, because it's smaller, so it don't have as much weight to it. So it don't take as much gas to go a certain distance. Whereas a big heavy car, right? You know, big heavy cars, just like a person, like I'm like 250, 260 pounds. So it takes more energy for me to run than it might take somebody that's 150 pounds or 120 pounds, right? Because I'm bigger, right? So I got to use up more energy to go the same distance as somebody else that is smaller, right? Cars operate the same way. So gas efficiency essentially measures, well, how much gasoline does it take to travel a certain distance? That's what gas efficiency is. And there's a formula for gas efficiency, which is this. Let me write this formula down, because this formula is going to be real helpful. Because if I don't know, like, I don't have my hard copy of the Eureka curriculum with me, but I don't think that they gave the formula for gas efficiency. I think they wanted you to just arrive at it, which is cool because it's a ratio. It's basically a ratio. So let me write this down. Gas efficiency is miles, the amount of miles traveled, divided by gallons of gas. All right, so if you look in your book, right, under the sports motorcycle, it talks about the first column, 5 gallons of gas, 287.5 miles. That means that if that gas tank was empty, right, nothing in it, and then you put 5 gallons of gas in that tank, right? If it held 5 gallons, I don't know how. See, this seemed a little crazy. Like, I think they just making stuff up. Well, I mean, you're not going. I mean, the typical gas tank in a motorcycle is not that big because at the end of the day, remember, it's a motorcycle. It's not a car, right? It's cars out there that got tanks that can hold 20 gallons of gas, and that's a large car. A motorcycle ain't holding 20 gallons of gas. They might talk about, you know, when you run out and got to gas up again, or just the prediction rate. But I doubt that there's even motorcycles out there that'll hold 10 gallons. Maybe that might be the max, 10 gallons. I would have to do my research. Well, you could do your research. You could go find out. But so look at how it says 5 gallons of gas, and underneath of it, it says 287.5 adjacent to the miles. So to find the gas efficiency, we would simply replace the word miles with 287.5, replace gallons of gas with the number 5. And then we take out our calculator and divide that. So let's just do that. Let's do that because what we're trying to do, I don't know if I read this already. We're trying to find out, okay, which motorcycle is more gas efficient and by how much? So we got to answer 2 questions. Which motorcycle is more gas efficient and by how much? Now, when you want to find the gas efficiency of the sports motorcycle, we can pick any 2 of those numbers. It doesn't matter, right? We can pick the numbers from the first column, the 5 and the 287.5. We can pick the second column, the 10 and the 57.5. We can pick the 15 and the 862.5. It doesn't matter. I'm going to just pick the first column. I'm going to just do it like this. I'm going to do, so miles, 287.5. The gallons of gas that will allow you to travel that far is 5 gallons. You need 5 gallons of gas to go this far. That's what that table means. You need 5 gallons of gas to go this far before you run out of gas again. But you really shouldn't go that far because if you go that far, you're going to run out of gas. So a little bit before you travel that far, you should get to the gas station. So you don't end up running out of gas and then have to walk your bike to the gas station or get it towed or something or whatever, right? So the gallons of gas is going to be 5. So now we're doing this. Grab your calculator. So we got 287.5 divided by, not multiplied. Remember, the fraction bar means division. Don't forget that. And I get 57.5. So that means that on this sports bike, the gas efficiency is 57.5 miles per gallon. 57.5 miles per gallon. So you ride on your bike, every time you go 57.5 miles, you burnt a gallon of gas. All right? You burnt a gallon of gas. Now, actually, this probably is assuming, I mean, this probably don't get into all that, right? But there's a difference between highway mileage and city mileage. Highway mileage is usually higher than city mileage because it takes more energy to accelerate. And if you just on the highway, just out, you know, you're not going to be doing as much start and stop travel, right? Because in the city, you're going to stop at a red light. You might have been going 50 miles an hour. You slow down, hit the brakes, you stop at a red light, you come to a complete stop. Then you start up again. That takes a lot of energy to start up again, right? Because you're starting and stopping. So city mileage is even lower because it burns more gas. You burn more gas by starting from 0, as opposed to if you was already going 40 miles an hour and then you kick it up to 60, or you was already going 50 miles an hour, you kick it up to 60, or you just going 60 consistently. You know what I mean? So anyway, the sports motorcycle, and let me put an S here. Well, let me see. Let me just write it right here. That's for the sports bike. The sports bike has a gas efficiency of 57.5 miles per hour. I'm sorry, not per hour, miles per gallon. Now, it asks about which one is more efficient. So that means now I got to go to the leisure bike. So the leisure bike, they give you a graph, right? So we got, let me see, 0 is right here. We got 2, we got 4, we got 6, we got 8, we got 10. Yeah, we do some vertical values. So we got 0 and then we got 110. Then these just keep doubling. Well, actually, no, they go up by 100. We'll go up by 110, 220, then we go into 330, then we go into 440, then we go into 550. You know what I mean? But anyway, according to the graph, we got, let me see, this is gallons and this is miles, right? So 2 gallons of gas for 110, and it consecutively goes up. Right? All right. Now, these dots are coordinates. They're coordinates. Each of these dots has a X value and a Y value. An X value and a Y value. This would be your X axis. This would be the Y axis. All right. So this dot has a value of 2 and 110. This dot has a value of 4 and 220. And so on and so forth, right? So this is the gallons of gas across the x-axis. This is the miles across the y-axis. So we want to know the gas efficiency. So all we got to do is pick one of those dots. Just one of those dots. We don't got to pick 2 of them, 3 of them, 4 of them. All we got to do is pick one of those dots. I'm gonna pick the lowest one, 2 and 110. And we do the same thing. Divide the number of miles by the gallons of gas required to go that amount of miles. All right? So this is what I'm going to do. Miles divided by gallons. So the number of miles is 110. Because look, that dot is at 2 and 110. 110 is right here. That's the mileage. 110. So I'm going to put a 110 in my numerator. I'm going to replace the word miles with 110. Then the question is, okay, well, how many gallons of gas do it take to go 110 miles? Go back to the point. 2 in common 110. 2 is my X value. So it takes 2 gallons to go that far. It takes 2 gallons to go that far. So 2 is my X. 2 is the number of gallons. So I replace the word gallons with a 2. And then I do the math. I do 110 divided by 2. 110 divided by 2, I could do that off the top. That's 55. MPG, miles per gallon. That's 55 miles per gallon. Now you can also put it in the calculator. Calculator will tell you the same thing. 110 divided by 2 is 55. All right. So I got 55 miles per gallon. Now the first question is, which type of bike, the sports bike or the leisure bike, has a better gas efficiency? Better gas efficiency is when you have higher. You want a higher. The higher the gas efficiency, the better. Because that means you can go more miles on the same amount of gas. Because look, on that sports bike, off 1 gallon of gas, you can go 57.5 miles. Off the leisure bike, off 1 gallon of gas, you can go 55 miles per gallon. Which number is bigger? 57.5. That's bigger. 57.5 miles per gallon. And when it says per gallon, that means per 1 gallon or per each gallon. That's what that means. Now, there might be some other bikes out here. You might be able to go 60 miles per gallon. Like the lighter the bike is, theoretically, the lighter the bike is or the smaller the bike is, the more miles you can go up the same amount of gas, theoretically. So keep that in mind. But that's only the first question. Which type of bike has the better gas efficiency? The next question is, by how much? By how much? By how much? That means we're doing a comparison. By how much? So we're just going to subtract 57.5 minus 55, which is 2.5. 2.5. Basically, And actually, I couldn't say miles per gallon. We could just say miles, about 2.5 miles. Because of 1 gallon of gas, this sports bike is going to be able to travel 2.5 miles further. 2.5 miles further. That's all that's going on, right? So yeah, so look, and this is another example of how we use unit rates, right? Because the unit rate is basically off 1 gallon of gas. Unit rate, one gallon of gas, right? Unit rate for the sports bike is 57.5 miles per gallon. The unit rate for the leisure bike, based on this graph, is 55 miles per gallon. So again, we're using unit rate, we're using ratios. This is a ratio. This fraction right here is a ratio. All fractions are ratios. All right. We didn't get into proportions. I didn't use a proportion for this problem. Perhaps we could have, but we didn't need to. We didn't need to. All right. So that is letter F from the Eureka Math Curriculum, grade 6, module 1, lesson 20, problem letter F. All right. So what you should do is go find some more problems just like that and practice. Go find some more problems just like that and practice. Because if you don't practice, you will forget how to do these types of problems. All right? So you go get some practice, and I will catch up with you in the next video. Peace.